Hello and welcome to the Argyle A Summit, Unlocking the Future with Artificial Intelligence. My name is Vicki Lim with Argyle. It's great to have everyone joining us today. Just a couple of notes before I turn things over to our esteemed speaker for this session. First, a quick reminder to stop by our sponsor's virtual booth at any time during the event and for the following week. Our partners are committed to providing you with valuable content and a great overall experience today. At any time during the event, you can visit the virtual booth from the main agenda page, and those do include complimentary materials, information, and meet and greet opportunities. To ask questions throughout this session and all sessions, simply type into the Q&A chat and we will address your questions at the end of the session. And also be sure to subscribe to Argyle on YouTube for exclusive access to all of our past events. And now, without further delay, I'd like to introduce our speaker, Pedro Solero, Chief AI Officer at Opnova. We are so excited to have Pedro with us for a thought leadership presentation titled Building Trustworthy Computer Use Agents. Welcome, Pedro, and over to you.
Thank you, Vicky Lynn. Hello, everyone. It's a pleasure to be here. I'm Pedro, co-founder and Chief AI Officer at Opnova, an enterprise AI automation startup building computer use agents for the enterprise. And I really want to start with a contextualization from some of the headlines we have seen throughout this year, as agentic AI being the top strategic technology trend for 2025, to the very recent article of A16Z, one of the leading VC companies in the world, with the title The Rise of Computer Use and Agentic Co-workers, in which basically they envision a world in which startups that master how to build computer use agents that work in the enterprise, that understand context and policies within the enterprise, that will be in the front line to build the true agentic co-workers that will reshape the digital labor across different industries. This is a bold statement, and VCs typically are really looking to the future with that respect. But we can also look as Microsoft is pouring this agentic revolution, as we should think of agents as the new apps for an AI powered world. So basically, the agents being the interface in which we perform work, and we basically orchestrate and use technology in general. So I also want to show you a release from Anthropic with the computer use model. They were the first releasing this type of capability, and you are seeing here a demonstration of a demo of that computer use model, in which the operator is asking what is the best place to watch sunrise in San Francisco, because they have a friend visiting. So this is kind of an intent planning something ahead of time. And what the agent is doing is orchestrating the browser, the maps on the computer, and use Google to find the best places, and now go into maps to find how long it takes to get there, and we'll create a calendar event based on the time of sunrise on the day after. So basically, the agent was able to understand the intent and the goal of the operator. It was able to plan accordingly, to break down that goal in multiple smaller tasks and execute each task sequentially to accomplish the goal of booking an event for a given day. So this is an example of the agent orchestrating, using, operating the computer as a human would do. So controlling the keyboard and the mouse and understanding what is on the screen. So there has been lots of advances in this area, and recently OpenAI incorporated these capabilities in ChatGPT itself. So they introduced a ChatGPT agent, which is basically doing what Anthropic was demoing before, but embedded in ChatGPT. And this means that we are giving control of our computer to ChatGPT, and ChatGPT will do tasks for us in our computer. It could be from accessing our calendar, accessing our email, or booking trips for us, like in this example with Expedia. So this a whole new world of possibilities, but there is also some nuances and risks that I also want to talk about. And A16Z really believes that the future of AI automation is already here. It's just a question of being productized in this new so-called AI revolution since the advent of generative AI and GPT models. So they really present this spectrum where we see on the lower axis, we see the level of human intelligence required to perform given tasks. And of course, there is several tasks that are already automated. We have conventional automation there. We are talking about typical decision tree automations in which we automate tasks like if this happens, then do that. And basically, we have these kind of a simpler, high volume tasks that conventional automation has already automated. But now we are looking to these future of automating tasks that previously were not possible to be automated with conventional technology. And we're talking about getting reliable and accurate extraction from data. I've been working in AI for more than 15 years, and I remember in early days when we were trying to do OCR from PDF documents, and that was not reliable if we had to deal with multiple templating formats of the documents, which basically is what happens in real life when we have enterprise um, interacting with external companies, external suppliers, for instance, external customers, in which you cannot control the format of the template of the documents you receive from these third-party organizations. You can only basically control your own data standard inside organizations. But now we are seeing with using LLMs to parse and extract information from documents that we are getting to a very high accuracy levels that basically we are moving to the next stage on intelligent document processing. And of course, then moving to workflows in which we have tasks, but tasks that we usually had workflows that had some automation, then a human would intervene with some manual, confirmation, validation, and then a second part of automation would be triggered. And here we are thinking about having end-to-end AI automation in which the AI with human in the loop capabilities can reach out to a stakeholder to ask for approval, to ask for confirmation, to ask for inserting specific data, like imagine usernames and credentials. Or then we are moving more to the right side of this spectrum of intelligence required for tasks that we have to do in our daily jobs that are repetitive, mundane, and we really can leverage AI to automate those tasks. And we all have seen there's a flooding wave of new startups on copy outreach on sales emails, and we have seen like even those outreach are getting sophisticated every time. My LinkedIn inbox is really hard to tell these days what is actually a human or an AI trying to reach out. It's getting better and better over time, so it's already happening. And of course then moving to more realistic complex end-to-end process that very common. We're talking about finance operations in which you have to perform, for instance, reconciliation between supplier invoices and your internal records or ledger, in which you have to have approvals for accounts payable, for instance. So those are typical finance operations, and this is just an example. but we have like same in HR, even in IT, we may have complex, intricate workflows in which multiple stakeholders need to be contacted, and they may need to approve for an expense, and then you have someone else approving from the other business unit. So this may be complex, may be asynchronous, meaning that the process may start today, then something happened, then some in the future there is a trigger in which the state of an invoice or an account changes, and then a human is contacted. So it can really be complex and may have multiple stakeholders with non-standard inputs. It's just not a question of yes or no, but can be nuanced or almost conversational, in which people can comment on expense approvals, for instance, and the comments may be very nuanced from a human perspective, like I approved these, but we decided that this no longer should be this way. So the agent should be able to interpret and understand the nuances of the human language. And of course, talking about the future in which we'll be able to have the agents calling humans, having a conversation with humans while doing the work on the computer. And this could be internally, but can also be on outreach, on sales, it can be on customer service, but in which it's not just a voice agent that is an interface in which you receive a request from a human, like a robocall, and then you trigger a given workflow. We are really talking about having agentic capabilities on having human conversations, human input, while following internal policies of what the process should be. So this is really almost like a human operator doing the work that we have today. So this is kind of the spectrum of how A16Z see that there is a lot of room to create great products that will have a huge impact on the operation side of the enterprise. But now, I have I am a researcher at heart, and I really want to take a step back, and just from a conceptual perspective, discussing what is an intelligent agent. My LinkedIn is also flooded with many different definitions of agentic AI and intelligent agents. So I find this very enduring definition from the book of Artificial Intelligence: A Modern Approach from 1995, from Stuart Russell and Peter Norvig, in which they really define what is an intelligent agent. And for them, it's like intelligent agent perceives its environment via sensors and acts rationally upon that environment with its effectors. And then they have definition of what is a discrete and a continuous agent, but basically the most relevant properties that agents should be autonomous. They should react to the environment. So if the environment changes, they should be proactive and goal oriented in adapting to the changes on the environment to pursue the goals that they have in first place. And they should be able to interact with other agents through the environment. And then they have these schematics here, which is very common in textbooks, but I really want to bring this today because I'm going to show how this very canonical academic definition still holds today, because after 30 years, what we have today in this agentic AI world is exactly the same concept, the same framework, but at the light of what we have today. So today, with sensors, we have mobile phone cameras around the world everywhere, and it's very common to see actual robots in which they have the mobile phone as a camera. You can have screenshots from the computer, so that the sensor is what is the current state of your computer interface, which applications you have open, do you have a window maximized, are you on the browser, are you on a native applications. And we can also think about, everybody has seen Waymo taxi cars across San Francisco, and basically they can use also the camera, but also the radar and other sensors. So we can think about many different sensors that can be used today, and we also have um, environments that could be data. We have data lakes, enterprise data, we have web applications, we have mobile apps, we have desktop, we have phones, we have the actual physical world, and on effectors we also have Python interpreters, like coding agents are exploding. Cursor, Lovable, all these recent unicorns that really exploded in terms of revenue. They have these effects, which basically they understand your intention, the vibe coding, and they basically can interact with code interpreters to generate code and test code. And all of this is possible because we have LLMs as the brain of the agent, while 30 years ago, when Russell and Norvig proposed this framework, they were basically thinking about logic engines, rules engines, in which we have like dozens or thousands of rules that we had to code beforehand. That will be all the possible decisions that the agent could take. And today we have LLMs that can serve as brains for those agents. And the actions then are very direct calls on tools. So basically, what it is of function calling or tool calling is that we instruct the LLM, the brain of the agent, to respond with specific actions, which are ways of calling functions that we can then apply to the environment. And this could be SQL query, could be calling a given API, it could be clicking on specific coordinate on the screen, or it can even be uh, basically a function to the robotic arm to grasp with a given speed and force. And the LM agent is deciding what should be that function to be called. And basically, this is possible because there was this innovation of LLMs in the first place that can receive text as input and output text, and text could be a code or API calls. But also when the multimodal LLMs appeared back in 2023, that was really when it was possible to combine all these multimodalities from screenshots of the computer or frames of a camera, and being able to digest that as input for the LLM to decide what should be the next action to be applied to the environment. So basically, what really makes this agentic AI revolution possible was using LLMs, and more specifically language, as a vehicle to define world interactions. And basically we can provide context of LLM, and there is a very typical prompt that people use for agents, which is you are helpful assistant. So this role playing with the LLMs, in which we define what is their purpose, and they'll be an assistant, and we then can prompt it to define that you can control a computer, you have access to the keyboard, have access to the mouse, you can drag and drop, you can move the mouse, the screen dimensions are X and Y. And basically, by giving that context to the LLM and then defining what should be their internal reasoning, how it should proceed when a given context shows up, and what tools are available, what actions can be called, it's possible to use LLMs to basically function as the brain of the agent, as I mentioned. And there's lots of low level capabilities that made this possible. And one of that is in context learning, which basically allows these agents to learn from the context we pass. And this is fundamental on the AI automation world, because when we give context of workflows, when we provide context on where we are going, then it's definitely necessary to understand what actions are available in that context. So we come up to the challenging trade-offs part. So basically, we, sorry, just a moment, I was getting some. Basically, we're coming to the trade-offs part. So basically, as these agent capabilities expand, there will be a tendency to delegate broader responsibilities. So as the agents show that they are able to perform work, we will get significant productivity gains and proportional greater risks, especially if we are considering, using raw agents without specific guardrails and systems to orchestrate. And one thing is to allow ChatGPT to control my computer while I'm, looking at the computer, looking at the screen in an attended mode, in which ChatGPT can use my personal credentials to log into websites or to my email and fetch data. Another completely different setup is in the enterprise, in which we want to delegate tasks to agents, and agents should operate in these sandbox environments in which they have access to a specific internal enterprise system of records. And we're talking about SAP, CRMs, and allowing the agent to perform that work is a completely different setup, and therefore there are completely different risks associated with that setup. And some of these risks come from these amplifiers in which we are not using Copilot, in which we are doing work together. We are using these autonomous agents that are doing the work themselves. So we are not working together. They are controlling their own computer or their own device, and they have increased autonomy. They have very limited direct oversight because they are doing lots of tasks. They can have very long action horizons. We have processes that can have hundreds and hundreds of steps, and they may have access to machines, to tools, to APIs, and they will have the ability to continue to learn and to get more context. And how do we control what is ingested to these agents is then something that is complex and must be addressed from ground up with specific platforms for that. So there are actions that are reversible. In early days, we had these discussions with customers in which they had an agent that in which they were doing a penetration test, and the tester was able to jailbreak, basically to do a prompt injection on the agent by asking it to run a script that basically deleted users from the Active Directory system, which you can think about is the sacred server of the enterprise who controls identity and authorization. And once these actions happen, they may be reversible. And we really need to be able to know when to defer or escalate to humans. And basically, if these agents are learning from context, if the context is biased, the agents can pick up those biases from understanding what is the policies they are putting in place. If they continue to operate for many, many months and years in the future, how do we manage what is its knowledge becomes a different risk. Also, something that in research is very interesting, like if you guarantee single agent security alignment, you cannot guarantee in a multi-agent setup that the same agent will be safe and secure when interacting with other agents. So there's another layer of challenge when we open the doors to have agents communicating with each other. I've worked in fraud detection, and GenAI is really boosting on the malicious side ways of trying to get access to systems if we don't have proper controls in place. Getting data from internal systems to outside if it's not proper robust and safe deployment. Who authorizes the agent to do some work? How do we centralize that control? So basically, as a key takeaway, I just want to say like the next wave of automation using computer agents is both appealing and worrisome, which for a researcher and product builder is always a challenge. And novel alignment and safety risks that require careful consideration and sense of urgency because there is a push to adopt, and it's all of these first principle approaches on how to build and integrate these agents that can be safely deployed in the enterprise is something that requires careful thought. We need reliable safety frameworks, better control mechanism, robust monitoring systems. Every decision, every action that the agent takes should be traced and audited in the future. We also need benchmarks for what the agent should not do. There are lots of benchmarks out there of what you expect the agent to do, but what about all the undesirable behaviors that we really don't want the agent to perform in the real world? And of course, last piece of advice, to partnership with teams who have deep domain expertise in responsible AI. And I'll stop here.
Thank you so much, Pedro. We do have a couple of questions that came in for the audience. We might have time for one or two, depending on the how in depth they are. The first question that came in is, where do you see the line between helpful autonomy and value misalignment that could create unintended consequences?
Well, thank you. The question is very relevant, and I'll try to address it in a couple of minutes. But it's something that we definitely would need longer time to address. But basically, the way we are addressing these risks at Opnova is that we consider that we are bringing to the environment of the agents the best practice from cybersecurity and responsible AI, meaning that we are creating an approach of least privilege to have access to systems. And that means on authorization, means on privileges, and also means access to applications, to context. If the agent is operating a given application that is internal, that machine should not have access to the internet. So the first place is really creating a safe deployment, like the sandbox I was mentioning, and then really having clear evaluation of what is success on each automation. And for that, that requires expertise on defining what is a successful outcome and what is an undesirable outcome. So exception handling, error handling becomes paramount in enterprise AI automation platforms.
Wonderful. Thank you so much, Pedro. Unfortunately, we are out of time. I wish that we had time. We certainly, any of the questions that we get in, we will send over to you post event. And thank you, Pedro, for such an insightful and practical thought leadership. And I want to thank everyone else for joining us for this session. This session, along with all of today's content, will be available on demand following the event. And our next session will begin at 1:10 p.m. Eastern Time, and that will be a keynote presentation titled Disruptive AI Trends in the New Innovation Era. Please click the join button that will appear on your screen to be directed to that session, and we look forward to seeing you there. Thank you again, Pedro.
Thank you so much. It was a pleasure.